this will be making noise of like clap. So just I remove. We need to just like insert this and press a little bit forward, and we just circle it around like that. So make sure you do not insert it insert fully it in the router. Either you can break the contents of the router inside the router. So just insert it a little bit and just press. So this is the router. So this is how the router is look. Before this, the tools I am using here, it's the router itself, then multimeter, then USB UART to serial converter, which is used to connect the UART to the our laptop, and we can listen the UART communication from there. Then the USB programmer, this will be used to extract the firmware from the ROM of the router. So, and these are like tweezers. So if we have multiple chips or circuits, so if you have multiple circuit like mini circuit boards like mini ICs or anything else, we can grab those with this type of tools. We can grab those with hand, but we have ESD, like electrostatic discharge, electrostatic current in ourselves, so we can damage the IC. Previously it happened by testing the router. I accidentally broke an IC through because of that, and the router fully was broke. So I before doing penetrating exploiting the routers, we have a setup in which we have an ESD, electrostatic discharger, it's like a mouse pad, big mouse pad, on which we keep the router, so it will not get damaged by this. So next is logic analyzer. We see the physical image, and this is the software image. So this is how our router looks. So these are the internals. So if you see this chip, this is the RAM chip of Z10. I have the model numbers which I am showing later. Then this is our main processor, and this is our ROM chip where our firmware is kept. And as you can see, these are the 4 pins which we will be connecting to get UART access. So these 4 pins not soldered, I installed this, but by default it was only the holes, and now after that I soldered to the external pins, so I can easily connect and remove the UART cable from it. So let's move next. So this is more closer look of that. So this is how the 4 pins looks, and this is our ROM chip. Then our UART, how our UART will be looking, our UART connection will be looking like. So we have first UART connection, then the Ethernet. Ethernet is for the Internet for the router. So I'll show you. So as you can see here, router. So before connecting to the UART, we need to identify which pins are used for what purposes. So that for that purposes, we can use a simple multimeter in order to understand what pins are used for what purpose. So I turn on the. So I am using this multimeter, and I set it to continuity test. Like you can see. test. So what is the when we connect to terminals, it beeps. So can you just see here? Beep. So what we are doing, what we are trying to do is connect a point of correct a point on the router. So let's say I to this point. This is like G and ground point for the router. So we all know we can get what current through the electric devices. We have an earthing point. So for the router, this is like low voltage. So there is no earthing point, but this is like a open ground point. So it will not get short circuit. So I am connecting this one end and try to connect those pins. Suppose this one. So it doesn't beep. This is not like connecting to each other. Second. Once I connect to second, this is like beeping. So this means this is our ground point. Then I try to connect the third. So no beep. So this is also so no beep. And fourth one is also no signal. So we got that the third point in this is ground point. So now to understand what other three are doing, what we can do is turn on the router. Just remember while you turning on the router, while testing like this, do not connect endpoints to each others, which could damage the router because we will connect circuits to each other. So we do not want to do that. So for that purpose, be careful when you start the router and trying to identify the pinouts. Next, the second point is what we found is ground. We need to find VCC and the TX and RX terminal for our UART connection. So in order to identify that, what we will do is we will set the multimeter to identify 20 volts of currents. So now the router is powered on, so there will be current flowing in the router. So what we are trying to do is how much current is flowing through the emitter pin. We are trying to see that. So if I try to get okay. I hope you can see. So if I try to connect it to front and see, you can see it is hopping to 3.32 low and high. So this means it is sending data between 3.3 volts to less. So this means this is our transmitter pin because it is sending data, and if we connect to the nearby pin of it, so as you can see there is 0 means it is not sending any data. This means this is receiving the current. This is listening for the current, means this is our receiver pin. And if we try to connect fourth pin, so it will be having zeros or 3.3 volt constant, 3.5 volt or 3.3 volt constant, not moving most of the cases. So this is our VCC pin. So and if most of the time routers will not come with label, but in this case this router has labels. So here you can see it is labeled VCC, then the second pin is GND for ground, then the RX and then the TX. So these are already labeled at the routers. If it doesn't have the label, we can identify those with the multimeter. So now we want to connect it to UART. So what we will do is use our UART adapter. So this is how our UART adapter is looking. So what we need to connect the TX, RX and ground pin to the we will connecting TX, RX and ground pins, and then we will be connecting those pins to the routers TX, RX and ground. And you might ask why we don't need the positive terminal VCC. So it's powered on by default, so we don't need any connection in order to connect we don't need any spread current for that. So that's why we will not using VCC. So first we will create connecting to ground. First I will connect the ground point, then on the routers right side. So this point is about RX point, and we need to connect with our UART connector. So the RX point is listening, and we want to send the data to the router. So that in that case we will be transmitting. So we need to connect the UART connector transmitter wire to the router's receiver point, and the router's transmitter point to the receiver point. So what we do, we will just connect the receiver end, UART receiver end to the router's TX pin, and the UART TX pin, router's receiver pin. Just connect down. Once we connect, we can do is open terminal. So now I will do use screen, and then the port at which our USB UART adapter is connected. So in my case, it's connected to so as you can see here it is mentioned access electronics port. Sorry. It was not connected now. So here is mentioned USB point UART reach. So in order to connect it with the UART, so we will use screen sudo screen, and then the USB port, the COM number. If you do Arduino programming, there is COM port for you in order to connect with Arduino devices. Similar in Linux, we have USB port. So dev PTY USB 0. This is the 0, and then the third parameter is baud rate. Baud rate is deciding on which frequency or which pattern we will transmitting or receiving that data. So in Arduino case, it is 9600. In UART or most IoT device case, it's 115,200. So we will try to connect screen. can see, this is the boot log which I was like talking about, the like services and running etc. modules, inserting modules, IP tables, rules, and etc. So here is the full boot log of how it looks. So first it's like setting up the boot or some things, then the U-boot boots, and then U-boot boot our operating system, like setting bus, RAM, memory, spy cache, and etc. things. Then it's Linux kernel started. Here our system started booting. Then here is the memory object. Like here it's mentioning the memory objects are like where the partitions are stored. Like boot partition is stored from this memory address to this memory address, and the kernel is stored from this memory address to memory. So like that, it stores the file systems. And here the initial serial terminal. So from which we got access. So this is sending data all the time. So it will be like scattering all around. Then if we type ID, so as you can see, there is no ID command from in this. So as I said, it is very limited to its functionality. Only the required tools will be present in this. So that's why. And as you can see, we have the root shell. So we got access to the router's root shell directly. We don't need any like special functionality or do anything exploitation in order to get root address, root access. So after this, what we can do is try to get like firmware from this. So as you can see, this is the file system of Linux. So like where like etc. directories, and if I add possibility, you can see there are 3 users: admin, drop here, and nobody. Admin is associated function service. So these are the contents of each file. So here is password backup files and sambar, result.com, etc. compilation files. We can directly try to access and modify them as we want. So if we look around in the firmware, just like I do, so I found an interesting directory in var tmp folder. So here you can see a drop layer directory which we can't access through the firmware that we get from the vendor. So if I go to the try to search for like TP-Link, EL, wait for my, I go to vendor page, I go to for support, firmware, and I try to download the firmware. Once it's downloaded, extract the firmware, extracted firmware is here, and here is .bin file. So what we can do is try to like extract or like see what will be the content of binwalk, what will be the content of files with binwalk. So I will just run binwalk with the file. So as you can see here, it's mentioned like first is the decimal like this is just telling about like this memory address. These are the things like you would found. Then in this memory address, to this memory address, we found the SJMA compressed data, which is our file system, and this is the second file system found. So once we extract the file system concrete, we will invoke as in, then the file name. So it's extracted file system for us. Once we ls, as you can see, there is a new folder. So we have these multiple files. The main folder which we are looking is cost device, and the second one is empty folder, and these two files like these squash method. This is compressed in squash FS, and this is like normal data file. We can use binwalk to extract firmware on this file also, but we will use similar squash method file system. Then this is in 7-zip. We have multiple formats in like same file. So when we go to the CD squash method, we will be getting the same Linux directories as we are getting in our UART access. And if we try to look into the file system here, LSVR directory, there is no files and folders. But if you look into the firmware side, there are files in value directory. So here you can see these are like configuration files or temporary files which are stored for temporary purpose. So ls var and then tp. So this contains a drop here directory. So once we get the drop here, so it contains a drop here VSS host key, an RSA host key, and a drop here password file. So we get the password file. We will get the password which is used to like connect the web interface, connect to the web interface of the router. But it will be encrypted, like use a hash function to encrypt it. So this is MD5, but we sorted. I tested it. So this is how we can access your terminal and try to analyze the file system and services from it. And here, as you can see, I didn't give all the commands access, just the basic ones. So to explain our access, we need full commands access. We can use our operating system to determine analyze this firmware. But if you want to access it at runtime, we don't have the full binary support at this level. So what we can do is we can host a server which will contain a busybox directory, which busybox binary file. Busybox is binary which contain all different types of binaries, like we have normal Linux utilities in it. Like basically it has the all commands, basic commands built into it. I will try it here. So if you have any doubt until the video starts.
What is the name of the BG box did you say? नाम क्या था? What was the name that you just mentioned? BG box?
हाँ, BG box. In order to share the BusyBox binary with the router, I need to connect it with the some kind of application. So where I can connect it with network. So I connected my routers. I connected my laptop to router's LAN port, so I can able to share my internet to the router. doubt? Any doubts? Ethernet is not connecting. Okay. So we discussed about the chips. So as I told, the RAM chip is about Z10, and this is the particular model number which we have. Then the memory, the processor, if it's MediaTek MT7628NN. Then the ROM chip, the SIG1 QD32 104 HIP. We can do the logic analyzer. So I have a logic analyzer also. I have this logic analyzer which I can use to connect the UART, and on UART I can listen the connection between the what UART is representing by in the sine wave pattern you can see here, and try to understand. Like you can see here, it's like showing. So it's mentioning here. So in hex or like normal bytes and other sign forms, we can use that and in order and analyze the data which you are transmitting if you don't know the pinouts in any case. So what we will be doing is like serving TFTP server on my machine and accessing the TFTP files which we are serving on the router. So I can transfer file in between them. While if I can call like here, I have the access to the router's UART. We continue. So what I try to do is like connect the UART and Ethernet and then transfer the PC box binary which contain all the basic utilities which are required in order to analyze the routers firmware or serial communication. So I can use that binary and access all the commands IoT basic command IoT tables and etc and extract and that's Python, basic Python. So I can use that and use that to analyze the router firmware or like share the file in between. I can use star and compress the files which I think I can import to me and then share it back to the my main laptop. Then next we will try to extract the firmware from the ROM chip. So in this, what we can do is we will need a USB programmer, in order to access the ROM. So we will disconnect the router because we don't need the router power. This is how the USB out programmer looks like. This is same method to the chip off method, where in which what we do is like remove the chip. Instead of removing the chip, we can access the as shown in the diagram. We can directly access this pin out. So what we are trying to do is directly connecting to those pins and extract firmware from that instead of removing the chip itself. The USB programmer looks like. And this is the cable by which this is like ROM. I will connect this to the chip. So I will show the connections. First, I will connect this to this adapter, which I can use to connect to this USB programmer. So the USB programmer also have two options, like here is mentioned. One is SPI. So as you can see, SPI and I2C. So this is SPI out SPI chip. So we will need to connect it to the SPI and connect. We just insert this. This should be just insert this and lock it. So now I can connect the USB programmer to my laptop, and this will be connected to the ROM on the router. And one more thing to keep in mind that if you look at the diagram, here is mentioned pin number 1. So it needs to be go to here, and once we connect this to the chip, we need to identify the first pin on this. So when we connect this to this, we need to identify the pin. We need to remember this the pin 1, and subsequently we need to connect that IC with that pin. So if you look at the diagram closely, you can see this small hole. So there is like small here is small hole type half hole, which is like sliding to that. This will be the first pin of the chip. So what I will do is like I don't know if you can see it now, but this pin has an pink single pin pin have a wire colored in pink. So this programmer we are using. So this board is like CH341 and which type of flash? So I'm 5 SDI, and then the hyphen dash option for the output file. So typically dot bin like for firmware type. So once I run the command, it will be like setting the firmware commit like here ready flash, and then so after getting the firmware, I am getting .bin file, so I can use that firmware to run it. I have one extracted firmware here. So as you can see, extracted firmware. So I extracted this firmware from the router, and here are the multiple CVs which I am testing for firmware for the router. I also have the router process firmware. Let's continue. So I will be exploring showcasing you buffer overflow vulnerability for this particular router. So basically here is the basic setup needed for that. As we can connect Ethernet, I will not show this, but these are the steps. So first we will create a JDB server on router with an attached PID of service. So what service we can use for this particular? They like exploited the HTTP service it was running for the server, web server, and they attached their HTTP service PID to this. Then attacker machine we will just tell you using the command gdb x gdb script in script we will like there is this information host information. Then the vulnerability like here is also like this vulnerability was found in HTTP header. So what basically happen is once we send the HTTP header, it goes like we can overflow the HTTP header. So this is like the vulnerable code at its lowest level. So this is like string copy simple function. Then vulnerable buffer and attacker control code. So this was the vulnerable buffer which we can control. So we like attacker code is gets copied to the vulnerable buffer. Then it is checked. So this is the exploit for that. So I will explain this exploit. So what is happening is here like first setting type is, then the web service module which is imported, and then creating a class of web service. Then creating the target address. Then these are some memory addresses which are like required, which the researchers got in the exploitation. Then it is called host padding, which is like overflow means we are like padding the host header with the multiple random values or like shallow values. Then the shell code the same as memory is setup. Then we are sending the exploit to the address first. So we will be sending shell code address mentioned, and this is like string. Generally we read the strings normal text. So in order to convert it to like binary or hexadecimal, this function p32 is used, and then we are using web service to make that call, and we sending host with host string as a header. Then we overflow buffer when the first step is set. So then we are sending the overflow like similar to we are limited to the binaries in the router itself. So what we are doing is like BusyBox provides multiple binaries which are required, basic binaries like command values in first time I add the ID command which was not found. So we can use BusyBox which contains the multiple binaries already compiled to single binary, and its size is only like 1 to 2 MB. So it varies like counting the all binaries which are required for that particular architecture and then using that. So BusyBox makes it easier to directly use single binary to do multiple architectures. Okay. So here we are sending it again with additional padding which making it overflow it worked or not. After that, we will be making a final call, and then when it's done, it will be executed. So here is the demo. So here it started. So basically, in this terminal, he is starting an netcat listener. On this, it is connected to router's serial connection. Then on third terminal, it will be exploiting using exploit. So here it started netcat listener. Then he executed the exploit. Once it executed, he is able to access the URL connection. Then like terminal access, and he is executing some commands over that. You can see. So this was the exploit. So any doubts or any question regarding this? Any question? Anything regarding session? How was it? Good, bad? And if you had any doubt, not but about the session, but in about IoT security or like anything else, web or like mobile, you can ask here. Professionals are present; they will answer it.
Guys, any questions? Please feel to ask questions.
सबको समझ आया क्या? Anyone?
There are no language barriers. You can ask in any language. Okay, thank you, Varun. That was a great session. I hope everyone has understood about the IoT security and how it works. So let's start the quiz. So those who are not in the group, can you please raise your hands so our volunteers can help them.